questions anyone might have. So, but as I said, I've been looking forward to this a lot. Amateur astronomy is an interest of mine, and it's very exciting to be able to share that with all of you here today. So, so without further ado, I'm going to share my screen, and just by showing a thumbs up, you can let me know if you can see it. I'll ask that you hold your questions until the end, but I definitely want to get to any questions that anybody has. So thank you for understanding that. So, all right. Can everyone confirm that they can see the slides? Thumbs up, good. Hopefully they're not cut off on the far side on the right. So, I really want to talk about something that I hope some of you have also had a chance to experience, which is seeing an eclipse, particularly of the sun. And I really want to share a little bit about the science behind why those occur, why I believe that they are one of the most amazing things that you can see in nature. Talk a little bit about my own experience seeing an eclipse about 3 years ago here in the United States. And I have a number of pictures and a couple of videos to share. So regrettably, I didn't take many of these pictures. There are photographers far better than myself, so I will defer to their expertise. So first, a little about me, for those who don't know me. My name's Peter Swanson. I've been at RSS for a little more than 5 years. I've been the director of the Adult Day Program for Memory Loss for that time. And one of the things that I think is exciting about RSS has been my chance to share my interests and passions with our members in different ways. So that's exactly what this is all about. I've been interested in astronomy for a long time, and this kind of topic is a natural for me. Just a little overview here about what we'll talk about today. So I have some slides prepared about the science behind eclipses, why they happen, when they happen, and to some extent where they happen. Talk a little bit about the different types of eclipses, the main two being eclipses of the sun and eclipses of the moon. And then we'll talk a little bit about the eclipse back in 2017, about 3 years ago, and what the experience was like where I saw it, which was in Silverton, Oregon. And then finally, I have a couple of slides for some upcoming eclipses here in North America in the actually not too distant future. So that's pretty exciting too. Also just quickly mention, the program is being recorded so that for future reference, you can come back to it. So just so you know. So without further ado, here we go. So I really want to start by talking a bit about the solar system as a whole, and a concept that I think is pretty important, as it relates to eclipses, which is really that our solar system is all about different kinds of cycles, and they're all happening at the same time, and when those cycles line up in just the right way, you can get an event like an eclipse that happens. So on this side, you've got all of the familiar planets, you've got the sun, and it's all a big system. And these things, they're rotating around the sun, they're rotating around their own axis. There's satellites revolving around many of the planets. And it's these cycles of rotation that when they line up perfectly, you get the ingredients that can let an eclipse happen. So I want to talk a little bit about some of the cycles of our own planet, the Earth. Most of these will be pretty familiar, to us because they define our everyday life. So one of the things, that I think is, pretty familiar is the cycle of the year. 365 days, 366 in a leap year. This is one of the cycles. So the Earth takes a different position, around the sun, and it takes roughly one of our calendar years, thus the measurement, for the Earth to roughly return to the same spot, in the orbit around the sun. So that's one of the cycles that's happening. Another cycle that's maybe a little less easy to know about is that the Earth is not always the same distance from the sun. There's a little adjustment, as that the orbit is not a perfect circle. It's more like an oval, than a circle, but a very slight oval. And so you've got, times where the Earth is a little closer to the sun and where the Earth is a little farther. It's imperceptible to us, on Earth, but when it comes to making an eclipse happen, it can make all the difference between the disk of the sun appearing larger or smaller as a result. So those things are called aphelion and parhelion. Those are your scientific terms for farthest from the sun and closest to the sun, respectively. So that's another cycle. Another cycle, and one that's certainly familiar, is the rotation on the Earth's own axis. So if you can imagine the Earth like a top that spins around a point, it's exactly what the Earth is doing. How we experience that is the day-night cycle. So as the Earth rotates, we have the experience of daytime when that part of the Earth is facing the sun, and that time where we're not facing the sun, which is what we experience as night. So that's also happening. So there's another cycle. And then finally, there's another cycle, the seasonal cycle. So the Earth not only spins on that axis like a top, but it also tilts a little bit. So that we experience as seasons. So when part of the Earth is facing more towards the sun, that part of the Earth tends to experience summer. As we do here in the Northern Hemisphere, we experience summer during June, July, and August. But this time of year, it's end of September, our part of the Earth is tilting a little bit further away from the sun as we experience winter here coming January, February, that'll be winter. So we also see it as the length of days is different. If that tilt makes the day length different. So all of these four things are happening at the same time, all the time. So the Earth, even though we're sitting here still in space, I'm sitting, here in my living room, all of these different things that we're moving constantly, from a planetary point of view. So then, at the same time as all of that, you've also got cycles of the moon. The moon is also doing its own types of movement. So the moon orbits the Earth. So what happens there is that there are times where we are able to see the moon and it has a defined shape, and there are times where we can't. And how we visually see that is in phases of the moon. So you're probably familiar with the full moon, where you could basically see the entire disk of the moon. And you're familiar with the moon, growing bigger from a crescent to a half moon, to what they call a gibbous moon, to full moon, and then all the way back again until you can't see it anymore. That's a cycle that's constantly happening. And it's roughly every 29 days, where that happens, where you go from, what's called a new moon, where you can't see it, and I'll get into why in a second, to a full moon and back again. So that's about 29 days. So that's a cycle that's happening. Another cycle that's happening is something called the nodes. This is a little more complicated to explain, but I'll do my best. So if you can imagine that the moon does not travel in an exactly straight path in the sky. It goes above and below kind of a center point. That center point has a name that astronomers give it. It's called the ecliptic. So if you can imagine a line where you draw it across the whole sky, you'll be able to see things such as the moon along that line or within a few, a little bit of distance from it. So when the moon crosses that line, that's a moment where it's possible for the Earth, Moon, and Sun to line up, and that's what's going to cause the eclipses we're going to talk about in a second. But knowing that the moon crosses the line either in an upward direction, thus the ascending node, or the other direction, descending. So it's another form of movement. And lastly, much like the Earth is, a little closer to, a little farther from the sun, so too is the moon. So that's got a different name, apogee and perigee. In other words, the furthest and closest the moon is to the Earth. So again, all of these cycles are happening at the same time. So it's kind of complicated, right? So when you put it all together, I've got a little diagram here. So when you put it all together, and you've got the sun here, and you've got the small moon here, and you've got the Earth here, you've got a situation where sometimes it's going to line up perfectly, where the moon, Earth, and sun are going to basically be in a straight line from a particular point. When that happens, it's possible for somewhere on Earth to see an eclipse. So it's all those cycles put together. When they just miraculously line up, that's what happens. So fortunately, there are people able to make calculations, when that happens, because I don't know about you, but that would be a lot to keep track of in my head. So I like to call it the cosmic ballet because of all of these things are happening at the same time. So, and as I said, we have an eclipse, either of the sun or moon, when everything is what I call the perfect alignment. There's even a funny word for it. You'll love this word for Scrabble if you're ever stuck with 3 Y's and no idea what to do. The alignment has actually got a name. It's called syzygy. So SYZYGY. There's a $50 word for you. So when that happens, you can possibly see an eclipse. So really depending on where that alignment can be seen, from a certain perspective. So solar eclipses, in other words, where the sun is either partially or totally blocked by the moon, are only possible when the moon is between the Earth and the sun. So that happens only during the new moon. In other words, the phase where we can't see it at all. The reason for that is because it's too close to the sun for us to see it. The sun's too bright for us to see it otherwise. And then the other situation, a lunar eclipse, is only possible during a full moon when the Earth can cast its shadow on the moon and you can see it, from your perspective. That's only possible during a full moon when the Earth, is between the sun and the moon. So now what's interesting about all of this is that when you put all these cycles together, it actually turns out that there's a pattern that can be followed. And roughly about every 18 years or so, the circumstances that cause an eclipse will happen again. So it's called the Saros cycle, and that's constantly ongoing. And so that's how scientists can know, oh, this is where the eclipses are going to happen. But it's a little different. It's not exactly 18 years. It's like 18 years, a few days, and a few hours. So where an eclipse happened before is not necessarily going to be exactly where it's going to happen again. So I have another image here that will kind of show, this cosmic ballet from another perspective. So you've got the Earth here in the middle and the positions of the moon on either side, where the new moon, where the Earth is where the moon is between the sun and the Earth, is when the solar eclipse can happen. And then when the moon's on the other side of the Earth is between the moon and the sun, that's when the lunar eclipses are possible. So this is another way to look at that same concept visually. So I should also mention I'm going to make these slides available to everyone at the end. So if you ever want to refer back to these, I'd be happy to share them with you all. So I talked a little bit about types of eclipses. So eclipses are not always the same. So in a solar eclipse, this is where the moon shadow falls on Earth. The alignment has to be just right for, the eclipse to be seen either at a partial phase where the moon partially covers the sun, the alignment is not perfect, a total eclipse where the moon exactly covers the sun, you can cover it up. That's what we're going to talk about here in the example. And then the annular eclipse where the moon's disk is too small to cover the sun completely. So you get a ring, or what's called an annulus, around the sun. So it's like a bright ring of fire, if you will. So all about that exact alignment determines the difference between a partial eclipse, total eclipse, and an annular eclipse. So, and then likewise, lunar eclipses also have two different types. And this is where the Earth's shadow falls on the moon. You get a total lunar eclipse when the moon is entirely, enveloped in the Earth's shadow. And then a partial lunar eclipse when the shadow misses the moon by some degree. So again, it's all about that alignment. And it's just little adjustments in that alignment can make all the difference. So I think I'm at the end of at least at the science part. I know I covered a lot of science, very quickly, but I want to get to the exciting part here. So I want to draw attention again to the fact that I wish I could take pictures this good, but I can't. So I want to talk a little bit about the eclipse back on August 21st, 2017. This I mentioned earlier, for those who heard me, this was something that I've been looking forward to for between 20 and 25 years. So I've been looking to this a long time. So I was going to make absolutely sure I was there to see it. So, this picture here, I'll get into what we're looking at here in a future slide. But I want to talk a little bit about that eclipse from that day. It was a Monday in the middle of the summer. This map here is of the United States, and it shows a yellow line going from the northeast toward the south, northwest toward the southeast. When an eclipse happens, it draws a solar eclipse anyway. It draws a line literally across the Earth where the shadow falls. So if you're standing anywhere within that yellow line, you would be able to see this total eclipse back on August 21st, 2017. So it passed through many major cities that day, including Salem, Oregon was one of them. Kansas City, Missouri was another. I believe, North Carolina? Charlotte, I think. South Carolina? I can forget. But many major cities were in this path. And if you were outside this path, you got to see some degree of the partial eclipse, where the alignment wasn't perfect. You had to be standing in exactly the right spot, in that yellow band, to see totality for this event. So I put together some facts for this eclipse. I talked a bit about the cycle. They number the cycles, the astronomers do. So this was a member of the cycle 145. There was an eclipse 18 years ago on August 11th, 1999. That was the previous one in this series. That might be important because it was one that was in Europe in that year, and many people traveled to Europe that particular year to see that eclipse. So it's interesting that 18 years later, kind of going to how the similar circumstances happened. 18 years later, the path was shifted to the west, and basically the same thing happened. It was just moved to the west. And so likewise, in 18 more years, it's going to happen again. It's going to shift to the west again. And so it's going to happen in Asia, probably around early September 2035 or so. The August 21st, 2017 eclipse was the first eclipse visible, total eclipse visible, I should say, in the continental US since February 26, 1979. It's 38 years. So it gives you a sense of how rare, particularly a total eclipse is. So, and I think that owes to, just how special such an event is if you have a chance to see it. So from the map, you can see it went from coast to coast, Oregon to South Carolina, and depending on where you were exactly in that path, the sun was blocked by the moon for a maximum of 2 minutes and 40 seconds. Seemingly an instant in time, but one well worth seeing. So I want to talk a little bit about some of the things that you can see. I have some pictures with some examples, to talk about these things. Probably one of the most obvious things is the visual phases. So as you're observing an eclipse, using safety measures like solar filter glasses, or other, kinds of devices. There's one pictured here. You can see the sun progressively getting blocked more and more by the moon. So this device here maybe not be big enough to see, but when you get the slides, you can enlarge it. There is a image of the crescent sun that's projected on the surface in the middle. So it's going through that lens, that refractor, and that light is hitting that surface. So instead of seeing a perfect circle, like you would normally expect from the sun, because the moon is partially blocking it, that's how you get the crescent. So it's one way you can see the shape of the sun during the partial phases, where the moon is progressively covering the sun more and more, or less and less, as it moves away. You can also perceptively see the light level change, particularly as it gets toward the total phase. And one of the videos I have will really show that. And then as it gets really close, you can see the shadow of the moon coming. It literally looks like a big, dark spot coming over the horizon at you, and then it just swallows you up. During the total phases, you can see, the different things that are never visible, with the sun. The sun, like the Earth, has an atmosphere. It's called the corona, that's only visible when the bright disk is blocked. There's also a phenomenon called the diamond ring, which happens when the last bits of sunlight, shine through moon valleys, because the moon, remember, it's not perfectly flat. It's, bumpy. So parts of it shine through, and that last bright spot, is visibly looks like a diamond ring. So I have a good picture of that too. Other things you can experience, animals often react to the sudden change in light level. It's like night's happening when it shouldn't. So some animals may behave differently, like birds, that don't expect eclipse to happen. The air temperature can also be perceptibly different, particularly during the summer, where the sunlight is blocked, which is the main source of heat during the summer. So I want to come to the YouTube video. So I'm going to break out of this screen share and move over to my web browser. Hopefully I can find that. So, Margie, did my screen share stop? Yes, it did. Okay. All right. No, that's not what I want. What are you doing? Okay. All right. Can someone just do a thumbs up, tell me that you can see my screen with the YouTube? Yes? Okay. So I'm going to show short video clips. They are speeded up a bit. One to kind of show from a distance, some of the phenomenon I talked about, and then others that will show the sun a little better resolution. So there's no sound with the videos. The videos will run, probably the first one about a minute and a half. The second will run probably about a minute or so. So I won't talk during the video, we'll just enjoy. So I'm going to go on to video number 2. So bear with me while I switch to that one. This one will show the sun from a little closer up. You can get a good sense of that diamond ring effect here.
White on the eyes to touch.
There's the diamond ring. All right. So I'm going to go back to my slides for the last little bit, but those are some pretty striking videos, even with no audio. Just the drama of the event. So I'm going to share the slides for the last little bit here, and then I'll open it up to questions. So sharing that, going back to play. All right, so here are some still images, that'll maybe echo from the videos that we just saw. So right at the beginning and end of the total phase of the eclipse, that part where you can see the light coming through just one little spot, that's called the diamond ring. That's what's shown on the image on the left. And then the solar atmosphere, that kind of shiny, thing, kind of radiating it out from the obscured disk of the sun, that's called the corona. It's the sun's atmosphere that you can only really see from Earth visually when the sun is totally eclipsed by the moon. So pretty incredible stuff. I also added a quick image here of the whole eclipse sequence, from beginning to end, where you can see, the sun slowly getting swallowed up, by the moon until it reaches that total phase, and then back again. The whole event from beginning to end probably lasts about 2 hours, at least in this case. The total phase, at least where I saw it, was about 2 minutes or so from where I saw it. So the last thing I want to do is share the excitement of a couple of upcoming eclipses. But, I forgot I had this slide. This was probably one of the most interesting images I ever found. So the International Space Station took a picture of the sun, the moon's shadow on the Earth, and that's that dark spot that you can see there. That is literally what is causing the eclipse to be seen from the ground. I thought this was an incredible shot, from this perspective. So I forgot I had this slide. um, so the last thing I want to do here before I open it up to any questions is to show you a couple of maps here of two upcoming eclipses in the pretty near future. So on Monday, October 14th, 2023, only about 3 years, there's going to be an annular solar eclipse, which is, again, the one where the moon doesn't completely cover the sun's disk because it's too small. You get that ring effect. Will be visible mostly in the southwest United States. This path looks like it's going to cross Albuquerque and Reno with some major cities, potentially, as well as some major cities in Texas as well. So this is only in about 3 years, not too long. And then finally, probably most excitingly, on Monday, April 8th, 2024, I also note that all these are on Mondays, which is the day named for the moon. Was that a coincidence? I don't know. This is a total eclipse. It's going to happen on the 8th of April in 2024, so about 3.5 years now. And this one's going to cross a path from Texas through the Northeast, actually. So this eclipse is going to be visible from places in New York, like Rochester and Buffalo, and includes Niagara Falls as well. And if you can imagine seeing such a thing from Niagara Falls, would be pretty amazing. So this is another one to look forward to. So that is the end of my slides. So I really want to turn this over to all of you for questions. And again, I want to say thank you for joining me and sharing in my interest here. So Margie, I'm not sure if people have the ability to mute or unmute themselves.
They have to unmute or unmute themselves.
Well,
we can't do it. Yeah, we can't do it. They have to do it themselves.
Okay, but they have the ability to.
Absolutely.
Okay, so at this point, I want to open it up to any questions that anyone has. I'm, an amateur astronomer at best, so I'll do my best to answer any questions.
Also, you can also use the chat function if you want to put a question or anything or a comment in the chat. You can use that also.
So I see a question from the chat from Michael Cook. Michael asked, I thought the next eclipse was in 2035. I just mentioned one in 2024. And yes, both are true, actually. So when I was mentioning 2035, I was specifically referring to the next eclipse in that particular sequence, that particular Saros sequence. But there are other Saros sequences happening at the same time, other circumstances that can allow eclipses to happen. So the eclipse that's coming up in 2024 is a member of a different sequence. So, and there's probably about maybe 20 or 25 sequences happening at the same time. So, but they repeat on about an 18-year cycle. So I hope that answers your question. I have a question from Donna in the chat asking about the YouTube links. I'm going to share the slides with everybody who is here. So if you registered for this class, via the website for RSS, you'll be able to get the links that way. So I see a question in the chat from Susan. Asks, how long have humans known about phases of the moon? So I'm not necessarily an expert on, history from antiquity, but I think as long as people have been able to observe the sky, I think people have known about those probably, since beginning of recorded history, if not earlier. I think our understanding has evolved a lot since then. We know a lot more about why, these things happen. But I think if you were to look at, historical artifacts and, what things that we can learn from history, that I think people have known about phases of the moon for quite a long time, but they might not have been able to predict with the degree of accuracy that we have today for eclipses. And in fact, I think in those older times, I think eclipses, since they weren't fully understood, were seen as an ill omen. like a sign, from a supreme power or supreme being, that needs to be taken seriously. Because what could be more powerful than destroying the sun, even if it's just for a few minutes? So I hope that answers your question, Susan.
Thank you.
You're welcome. So again, I'm happy to take any questions either from the chat or if you'd like to unmute yourself and ask.
Also, we observed a partial eclipse here in New York a couple of years ago. I can't, is that the same eclipse?
It may have been, it may have been. So at the same time as the total eclipse was happening in certain parts of the United States, if you're just outside that path, if you can kind of imagine that yellow ribbon that was drawn across the map of the United States, if you were outside of that yellow ribbon, you could still see an eclipse, but it would be partial. So for that event, New York City was outside of that ribbon, but you could have still seen, I'm thinking maybe about 75% of the sun eclipsed on that particular day.
Yeah, I think it was 75% because I saw it that day. I was going to Targets and we all stand outside just to wait for it to happen. And it was like 75% of the sun was blocked. And it was beautiful. I tell you, it was beautiful.
You got a chance to see it?
Amazing. Amazing.
Yeah, glad you got a chance to see it.
Oh, I did. Thank God for that. I've seen that.
I don't know that the path is going to cross New York City in any time that's going to be relevant for any of us. So we'll have to travel to see the total phase. But I'm glad that you got to see
that phase.
Thank you for sharing, Rini.
You're welcome.
I wanted to answer a question from Bob and Sue. The question was, what is the orientation of the moon in its orbit of the moon? So I think you might be asking about whether the moon also rotates on an axis. Can you kind of give me a sign? Yes? Bob and Sue, if you want to add that to the chat or just unmute and you can answer that directly. Okay, I will assume you are asking that. So, and the answer is yes, the moon does rotate, but it rotates at a very slow rate. So generally speaking, the side of the moon that we can see from the Earth is generally the same, but it changes slowly, much more slowly than the Earth's own rotation. I hope that answers your question. I see a comment from Karen in the chat. Says she went back into her photo library on her phone and said she found 4 pictures of the eclipse from August 21st, 2017. And that would be the day. That would be the day. So, and again, depending on where you were, you could see a partial or a total phase.
Another question?
Yeah, Roz, question?
We ever come up with new scientific facts that we didn't even expect from these eclipses?
So the question was, did we find out any scientific facts from these eclipses that we might not otherwise know? Was that your question?
Right.
Sure, and I would say the answer is yes. I think one of the things that we can observe about the sun that's not otherwise possible is that the sun's atmosphere, that corona, the sun is just too bright, to measure in visible light. If you look at the sun, you're blinded, can't do it, So when the eclipse is covered, we have the chance to look at that. And astronomers can see that even if it's for a brief period of time and take measurements that are not otherwise possible. So I think we've learned a great deal about the sun in particular from total eclipses because they let us see things that we can't see otherwise. We can measure the sun in other ways, but with visible light, the sun is just too bright, for us to see it, with our own eyes, without protection. So I think we've learned a lot, from that.
Hi, can you hear me?
I can indeed. Sue, is that you?
Yes, Bob and Sue. I wasn't too clear about my question before.
Okay.
When the moon revolves around the Earth, does it go from pole to pole? In other words, where is it in relation to the Earth?
Okay. So I'll cover that as well. So the moon follows a path in the sky that's called the ecliptic. So if you can imagine the equator of the Earth, right? Where like the middle of the Earth that divides the northern and the southern hemispheres, there's a similar phenomenon in the sky in what's called the celestial, sphere. So, and there's a line that um, that follows. The planets follow and the moon follows when we can see them from our point of view on the Earth's surface. So roughly, it's going to follow that line. So from a temperate latitude like New York, latitude 40 or so, it's going to follow a roughly middle of the sky, but during the summer months, the moon will be lower, in the sky. In the winter months, it'll be higher in the sky. But generally, it's not going to cross the pole. It really only does that in the tropics, where it can rise that high. It goes over what we see as the pole, by looking straight up.
Thank you.
I hope that answers your question. So also thanks for joining us. So I would love to connect with you. So more.
Thank you.
Sure. Did I miss any questions in the chat? Does not look like I did. So.
I just wanted to say that we really enjoy science, and I hope, thank you very much for sharing with us. And I hope there are more of these things in the future.
Sure. So
Yeah,
I did a talk on
really good stuff.
meteorology about 2 months ago. So, and I may do another, talk on a science topic in the future. This is sort of a side interest of mine that I don't often get to share, in my regular work with RSS. So, again, I'm happy to take any questions that anyone might have. Thank you for your, compliments in the chat. I appreciate it.
Yeah, it's really a nice session. I love it. At least you gave me some terminology on the lunar, the eclipse, the luna, and all that. So that was good. That was good.
I don't want to throw a lot of, vocabulary words out there.
No, I love it. Throw it all at me. I'll take it.
Next time they say it on Jeopardy, you'll know, right?
Right.
So,